Hello, Lockerbie. Lots of you were saying that you didn't really know what scalars and vectors are, so I'm going to introduce you to scalars and vectors. So some quantities are scalar quantities, and they can be fully described by a number, which is called a magnitude, and a unit. So these would be things like speed, mass, temperature. Some quantities, however, you need to include a direction. So they would be fully described by a magnitude, size, a unit, and a direction. And these quantities are vectors. Now, the easiest way to picture whether it's a scalar or vector quantity is by looking and thinking about forces, because forces are quite easy to picture that they are vector quantities, because if you've got two of you driving down the road, the car breaks down and you need to give it a push. If one person pushes from the front and one person pushes from the back, the car's not going to go anywhere, right, if you're pushing with the same force. But if the person who's pushing from the front runs around to the back and pushes the car from the back as well, then you might be able to move the car. You've not added any extra force. What you have done is you've put it in a different direction. So because you've changed the direction, you've got a different answer. So a force is an example of a vector quantity, where it's fully described with a magnitude or size, a unit, and a direction. So what we're going to do here is you can play along. I'm going to point to one and you've got to see whether it's a scalar or a vector and see how many you get right. So the first one, temperature, scalar. Time, scalar. If we could go back in time, that would be a vector, but we can't. So force, I've just been through that, vector. Displacement, if you remember that from second year, vector. Volume, scalar. Distance, scalar. Energy, scalar. Mass, scalar. Speed, scalar. Velocity, vector. Acceleration, vector. So basically what you want to do is you want to remember the vector quantities and everything else is a scalar. So any force is a vector, and then you've got displacement, acceleration, and velocity. Adding vectors, we're not going to go through this very detailed, okay? But if you add normal quantities, you've got a mass of 3 kilograms and 4 kilograms, so they would add up to a total of 7 kilograms. That's fine. And likewise, if you've got a force of 4 newtons and 3 newtons and they're going in the same direction, that would add up because they're in the same direction. So that would give us 7 newtons. However, if you've got 4 newtons pushing in one direction and 3 newtons in the other, so that's like pushing on the car again, you'll end up with an overall force of 1 newton to the right, because 3 newtons cancels out 3 of the newtons to the right from the push from the 3 newtons from the left. Pushing from the right towards the left. You can do this by a thing called scale diagrams. If you drew 4 centimetre line across the page and then did a 3 centimetre line back, that 1 centimetre line that would be left would be your resultant, or the overall force. Remember then, when you're giving an answer to a vector problem, you need to give the size, unit, and the direction, even if that's up, down, along. Okay, I won't for now go on and add vectors at right angles. These are the 2 common scalars and vectors that you've met already. So we've got distance, that is how far you've travelled, that is a scalar quantity. So here's my distance, going to walk along the road. Okay, if I'd done that straight, they would have been the same. I'm then going to go up. Okay, you can see now that the distance is much, bigger than my displacement, and I finish there. So this is where I've actually walked, the red line. That's my distance, which is, according to this, 46.4 meters. But I'm only 6.5 meters from where I started. And what's more, I'm at a bearing 0, 0, 0, which I hope you know is due north. Let's try another one. This is where I've got a problem. If I go in a straight line, which is almost a straight line, you could see that the distance and the displacement would have the same magnitude, but I would still need a bearing or a direction for my displacement. Okay, one other one that I think of, if I go all over the place, okay, this person's very funny because they can walk backwards as well as they can walk forwards, and we have a chat there, and we go back, okay. This is me doing my miles for Kirtle House, for the housing. And then I walk back to the start. Oh, excellent. You can see I've gone a distance of 322.9 meters, but my displacement, I'm back where I started from, so my displacement is 0. So notice that if the direction of travel has changed during the journey, the distance travelled and the displacement will have different magnitudes. If you go in a straight line, it's the only time when the magnitude, the size of your distance, will be the same as your displacement. So if you run a 100-meter race, because that's in a straight line, your distance run is 100 meters, your displacement is 100 meters, but you'd have to say your displacement is 100 meters along the track. Okay, shall we do a problem? I suppose we could. Okay, this depends on how far you know your trigonometry. So here, your boat rows 12 kilometres north, then heads 5 kilometres east. So the distance, which is how far you've travelled, that's a scalar quantity, so you can just add. So 12 plus 5 is 17 kilometres. But if you're looking at your displacement, you'd have to use Pythagoras. So if you remember that, the sum of the squares, so c squared, which is this one here, is equal to a squared, 12 squared, plus 5 squared. So 144 plus 25 is 169. Square root that comes out as 13 kilometres. Don't forget we need an angle, which you could measure, or you can use trigonometry for that. Okay, I'm not going to get you to do any of those at the moment. Okay, so the last look we're going to look at is the difference between speed and velocity. So again, speed is a scalar, velocity is a vector quantity. Some people think they're the same, and we can be a bit naughty in physics, and we can be a bit lax about our using of these terms. Okay, we're going to now look at speed and velocity, the other two vector quantities you should have met. So speed stands for it's got a scalar quantity. So your speed is your total distance over your time. So that's a scalar quantity. Your direction isn't important. If you travel, my car will do about 700 miles on a tank of fuel. Doesn't matter if I'm going north or south. Okay, after 700 miles, I need to fill up with fuel. So your speed is your total distance divided by your journey time, and that is a scalar quantity. But your velocity is a vector quantity. So again, how helpful is that? S for speed, S for scalar, V for velocity, V for vector. So if you're ever asked to give an example, choose those two and then you know which way round it is. And your velocity is your displacement divided by your time. So if you travel in a straight line, your speed and your velocity would have the same magnitude. Remember, your velocity would need a direction. Another thing about velocities, though, is we can also have negative velocities. And I'm going to show you this one here. So here I've got this little cart, and it's got a little spring in the front. So if I give this a push, okay, it's got a positive velocity. It then hits the wall and it goes backwards. And we describe that in physics as a negative velocity. So a negative velocity tells me that your vehicle has turned around and gone backwards. Okay, you can choose which way is positive, which way is negative, but we tend to use, think of drawing out the axis on a graph, and we tend to have things going to the right as positive, things going to the left as negative. We tend to have up as positive and down as negative, but that's for you to choose as well. That speed and velocity are similar but not the same, and that's because speed is a scalar, velocity is a vector. Distance and displacement are similar, but they're not the same. Distance is a scalar, displacement is a vector. One thing I hope you've read in the side notes is that gravitational field strength, quantity g, is also a vector quantity. The direction matters. A scalar is one which has size only. A vector has both size and direction. Distance is a scalar quantity. Displacement is a measure how far the starting point is from the finishing point. Don't know what it wants there. Speed, I assume. Speed is a scalar quantity. Velocity is a vector quantity. Velocity can be positive or negative. When drawing a vector diagram, the vectors should be added head to tail. And it looks like the numbers aren't working, but I can assure you that that's right. So I hope that's helped you understand the difference between scalars and vectors. I'll put a few extra videos in if you need some more help. Take care, bye. Okay, I hope you'll join along. A something quantity is one which has a size only. Scalar. A something quantity has size and direction. Vector. Distance is a scalar quantity. Displacement is a measure of how far the starting point is from the finishing point. Speed is a scalar. Yep, well done. Velocity is a vector. Velocity can be positive or negative. When drawing a vector diagram, the vectors should be added head to tail.